Okay, so now we're going to run into a problem that's going to test our understanding of how the theorem works. In how many ways can we choose three different numbers from the set 1, 2, 3, 4, 5, 6 such that the three numbers we picked could be the sides of a non-degenerate triangle? And we don't care if the order is different. 3, 4, 5 is the same as 4, 3, 5. So, a non-degenerate triangle means that we would have a situation where A plus B must be strictly greater than C. We cannot have equality in this situation. So let's start with casework. Case 1. And let's pick a number from this list. We'll start with 1 and we'll say, what if 1 is the smallest side? If 1 is the smallest side of the triangle, well, let's try out a few combinations. We could do 1, 2, and 3. So 1 plus 2, we want that to be greater than the third side, 3. But as we can see, this is not true. So that combination would not work. And from here, it should be obvious that we're not really going to get anything to work. So we could try 3 as the next side and 4, but that's not going to work either. So if we have that 1 is the small side, no combinations exist. Since no matter what, if you have 1 as your smallest side, no matter what your second side is, it's always going to be either equal to or less than the third side. So let's try case number 2. Case number 2 would be that 2 is the smallest side. And note, since we can't use 1 in our sides at all, we might as well get rid of that, since 1 can't be the smallest number. Well, let's try some sides out. What about 2 and 3? Is that greater than 4? Well, absolutely, because 2 plus 3 is 5, which is strictly greater than 4. So, one possible set is 2, 3, and 4. That absolutely works. Okay. Well, how about 2, 3, and 5? Well, that can't work because that would give equality. So I can't use 3 again. So let's try 2 and 4. 2 and 4, and then let's use 5. Well, is this true? Absolutely, because 6 is greater than 5. So another combination we have is 2, 4, and 5. And then let's try 2. Well, we tried, we could do 4 and 6, but we know that wouldn't work. So let's use 5 as our next side. Is that greater than 6? Well, absolutely, because 7 is greater than 6. So, lastly, we have 2, 5, and 6. Those are all the combinations where 2 is the small side. So, in total now, we have 3 combinations of sides that would work. We could have a triangle with sides 2, 3, and 4, 2, 4, and 5, 2, 5, and 6. So let's do case 3 now. Three is the smallest side. Well, we can't use 2 anymore since 3 is the smallest side. So let's try some combinations. We have 3 and 4. Does that work with 5? Well, absolutely, because 3 and 4 is 7. So one combination that works is 3, 4, and 5. Okay. How about, well, we know that 3 and 4 is 7, so that means 6 would also work as well. So we have 3, 4, and 6. Okay. So, is there anything else? Well, we could do 3 and then 5 as my next largest side. Is that greater than 6? Well, absolutely. So, 3, 5, and 6. And since we hit that upper limit, we can't use 6 twice. So, that's all the combinations we could work with there. So, now let's do case 4. Where 4 is the smallest side. Okay, now we can't use 3 anymore. But all we have left with is 4, 5, and 6. So 4 plus 5, is that greater than 6? Well, yeah, because 4 and 5 is 9. So we have a combination of 4, 5, and 6. And since that's our last remaining 3 sides, because there's 3 sides in the triangle, there's no other combinations we can use. So now we have listed every possible situation. And in total, we have 1, 2, 3, 4, 5, 6, 7 possible combinations. We have listed every situation where we would get a non-degenerate triangle.